We will consider questions where it's difficult to identify that they are based upon combination. One of the standard questions is, there are, let's say, 8 points in a plane and no 3 are collinear. Collinear means they would lying on the same line. So no 3 are collinear. A good way to ensure that no 3 are collinear is to take the points as if they were lying on a polygon. So I'll just take it as if they're lying on a octagon. So then no 3 will be collinear. 2 points anyways, any 2 points are always going to be collinear. And the question is, how many lines can be formed? The question is about lines using these points. So I will have to use these points only, and I will have to draw lines out over there. Now again, not a too difficult ones. To draw any line, I will have to use 2 points out over here. So if I start with this, I could take this point and draw 1 line. I could take this and I draw a second line. I could take this and I could draw a third line. Is it okay? So one way to think about it is, from any point, there are 7 different points lines. So from each point I could draw 7 lines. Right, so I'm just drawing it and showing it to you with one of them. So these are the 7 different lines. And can the same process be repeated with the second point also? So with A I can draw 7 lines, with B I can draw 7 lines, with C I can draw 7 lines, and there are 8 such points. So the answer would become 7 into 8. However, if you look at it, this line AB, have I counted it from A and have I counted the same line from B as well? Each line will be counted twice, so we would be dividing it by 2 to get an answer. We have answered this question logically itself without the use of any permutation comments. What is the use of PNC here? What is the use of combination? To draw a line, could I say every pair of points? Take any pair of points out over here. So if I would just quickly redraw it out over there. So there's A, B, C, D, E, F, G, H. So these are your 8 points. Take any pair of the lines. Let's say A and B, or A and this point out over here, B, C, D, E. Would I get a line? Yes. And tell me, is the line AE different from EA? No, it's the same line. So the order does not matter, it is just the pairing. So in how many ways can I pair up? And pair up means nothing but selecting 2 of them. From how many of them? 8. And do we see that 8C2 is same as 8 into 7 by 2? So we could even use combination here and get to answer. Okay, let us just continue this point and say, continue this question and change it to, how many diagonals in an octagon? So we were anyways dealing with an octagon, and diagonals are nothing but lines. So is the answer going to be the same? We are not looking at just lines, we are now using diagonals. And so what is the only difference? Each of these are acceptable. These all are diagonals. However, what is not acceptable is this line here. Why is this not acceptable? Because it becomes a side. Similarly, this would become a side, so it is not acceptable. So this is same like the previous question. Draw all the possible lines, but this time what do we do? From all the possible lines, let me use an 8C2 itself in that case, 8C2. I would just subtract the number of sides. In any n-gon is which has n vertices, the answer is going to be straight NC2 minus n. And if you work this out, NC2 minus n, you will get to an interesting format. Let's discuss this here itself. So let's take a polygon which has n points total. There are total of n points or n vertices. Let me start with any one vertex A. If there are n points in this plane out over here, how many diagonals can I form? Can I form a diagonal with the adjacent one? Not really. But can I form it with the next one? Yes. With the next one? Yes. With the next one? Yes. Until here, could I form a diagonal with the immediate one on the clockwise? No. So, n points in all, 1 itself, take it out. the adjacent one not acceptable, the next adjacent not acceptable. So from each point I will be able to draw n minus 3 diagonals. From point B, how many diagonals would I be able to form? Same n minus 3. So from n points it would be into n. Same logic, each diagonal will be counted twice from each vertex. So we could also think of it as n into n minus 3 by 2. If you solve NC2 minus n, you are going to get the same answer out over there. So this is about finding the diagonals in this case. To continue similar questions, so let's stick with lines for a minute. We have 10 lines or 10 points on a plane. However, now of which let's say 4 are collinear. And it says no other 3 points are collinear. No other 3 are collinear. Find the number of lines using these points. So the question is same. What is the difference here? Now there are some collinear lines. So let collinear points. So 1, 2, 3, 4. 4 points are collinear, and there are 6 other points which none 3 are collinear in that case. 3, 4, 5, 6. Again, rather than do a piecemeal approach, that one point from here could be connected with any of the remaining 6 points, they cannot be connected among themselves. A simple way is, forget the fact that they are collinear and just count all the total lines, which is nothing but 10C2. So in 10C2, have I included every possible line like the previous one? Yes. But with the point A, have I also selected AB and drawn a line? Yes. With the point A, have I also selected AC and drawn a line? Pretty much. And AD. Would I have also selected the second and the third point and drawn a line? Yes. I would have counted this line many times. How many times would I have counted this line? As many pairs as I can form from these collinear ones. So how many can I form from these 4 points? How many pairs? 4C2. So I would have counted that line 4C2 times. So subtracted, but when we subtracted, we have subtracted each of these lines. Is there one of those lines? So to complete the answer, I would add a 1 back to this. So you can continue with this logic anywhere, whatever be the collinear points in that case, right? A cat question coming up, and there are as easy questions also. This cat question is, there are 10 points on a straight line. So I'm just writing it out, 10 points, this is on a straight line. And there are 11 points on another straight line which is parallel to the previous one. So the lines are parallel, 10 points on the first one, 11 points on the second one. And the question is, how many triangles can be formed, right, such that their vertices are going to be one of these points. How can I form a triangle? To form a triangle, can I form it in a straight line? No. So again, it should be pretty obvious. I would be possibly taking 2 points from L1 and 1 point from L2. That could be done in 10C2 ways. And 1 point from L2 will be done in 11C1 ways. Why am I interested in a C? Because a triangle ABC is same as BAC. The order does not matter. Or I could take 1 point from the first line, and then I would have to take 2 points on the second line. Whenever you do this, do think about it. Is there going to be any double counting? Let's see. I've taken 2 from the first one, so this would be triangles of this type. So let's say the pointed part would be down. Here 1 point is taken from the above and 2 points from the below line. There can never be any triangle which will be counted twice out over here. So this is going to be my answer. If I would say, is there another possibility out over here? Let's say this is first answer and this is a correct answer. What if I start by saying, oh, there are 21 points in all, select any 3. Why 3? Because 3 points will give a triangle. We obviously know this is not the complete answer, but can I complete it in this sense? Yes. So I've selected any 3 out of the 21. Which ones will not form a triangle? 3 selected from the first one, so 10C3 will not form a triangle. 3 selected from the second line will also not form a triangle, and the 2 of them are going to be identical in numerical value. So this is about forming triangles from the points. So they seem to be different, but you are using a combination funda here itself. And one more out over here. We will, let's say there are 6 6 parallel lines, 1, 2, 3, 4, 5, 6, and there are another set of 5 parallel lines which intersect the earlier 6. And the question is, how many parallelograms can we form? Can be found in this grid? How many parallelograms in this grid? Okay. To a very beginner, these could only be the non-overlapping parallelogram. This is the first. So if I just count 1, 2, 3, 4, 5, 5 in a row. First row, second row, third row, fourth row, 5 fours are 20. But that's a very, totally a non-beginner's error sort of thing, right? These are non-overlapping parallelograms. Could I also form a parallelogram of this type? This is also parallelogram which I would have not counted. This is 2 parallelograms together. Or could I have a parallelogram of this shape here? In this case, so let me just draw it with a dotted one out over here. So there are plenty of parallelograms which overlap each other, right? So I need to count all of them. And how would I be doing this? After a lot, if one is not aware of the solution to this, one might end up spending a lot of time using the vertices or so on, right? But a simple way is parallelograms are not formed using the vertices. The parallelograms are formed using the lines. So a simple way is select any 2 lines from the one set, select any 2 lines from out of these 5 lines, and also select any 2 lines, select any 2 from the other set of parallel lines. Each selection is going to result into a distinct parallelogram. For example, let's name them as P, Q, R, S and T, and the other one says A, B, C, D, E and F. To form the dotted parallelogram, which are the lines that one has to select? One has to select the line Q and T from the first one, and from the vertical D. So if I've done these selections, I would be getting only one parallelogram. Can this parallelogram be obtained by any other selection? Not really, right? So each selection will result into one parallelogram. One parallelogram means a single selection. So in how many ways can I select 2 lines out of 5? So the answer is 5C2. For every selection, having selected Q and T, I could select any combination from this, that is 6C2 ways. So the answer is 5C2 into 6C2 ways out over here. This is the number of parallelograms. Had these lines been perpendicular to each other, it would result nothing but in the sort of a chessboard that we have. I'll not draw a complete chessboard, but just a part of it. So had they been perpendicular out over there, the parallelograms would have become a rectangular, and had they been equidistant from each other, then they would become into a square, right? So if the question is being asked, so each individual would be a square, right? So if the question is asked, how many rectangles are there out over here? So if you want a rectangle, square is a rectangle, so that would be obviously 16, but isn't this also a rectangle? Isn't this vertical one also a rectangle? So the same logic works, and you would be doing similar working here. Why I'm talking about this? How many rectangles on a chessboard? Quite a few of us know the logic, approach it correctly. This is same like the parallelogram question, and come up with an answer 8C2 into 8C2. Take any lines from the vertical and so on. So this is the only reason why I'm mentioning it. This is wrong while your logic is correct. There are 8 rows and columns, and 8 rows and columns results into 9 vertical lines, and 8 columns is 9 horizontal lines, or so on. So the answer to this question is going to be 9C2 into 9C2. I hope you have got the correct one. So don't make a silly error out over here just because you got confused with the rows and the lines. And a related question, though not about permutation and combination here, is about how many squares are there. So I'll just do this very quickly out over here. In the grid that I had shown earlier in terms of a 4x4, how many squares are there? Now there's a condition that I cannot be taking any 2 lines randomly. The logic goes by counting number of squares of sizes. So let's say each one of them is 1 unit. So 1 by 1, The non-overlapping squares, they are 16 of them. Let's take a square 2 by 2 centimeter. So if I take a 2 by 2 centimeter, if I'm using this, I would have to use this one out over here. So this is a 2 by 2 out over here. Let's just rotate this. This is currently out over here. Could I go to the next one? So that's a second, then a third. Go downwards, fourth, fifth, sixth, seventh, and then an eighth. And inside there would be one more out over here, so there are going to be 9 such things. Let's try it for 3 by 3 out over here. So if I start from, quickly, if I start from the top left corner, think of it this way, I start from the top left corner, I would be able to form a square in this particular way. This is the 3 by 3 square I have. Now just rotate the square anywhere. So I have one square, move it little right, I'll get a second one, move it down, third one, and then a fourth one. There's nothing in the middle, there are 4. And how about a square of the size 4 by 4? There's nothing but the entire grid 1. What do these suggest? 1, 4, 9, 16 should suggest that they are perfect squares. So the number of squares in a chessboard is going to be nothing but 1 plus 4 plus 9 plus 16 and so on till 8 square. Sum of squares till 8 square, which is going to be 204 in that case. To wind the session up, so we did plenty of questions dealing with the plane and points and lines and so on. Just a unique different question. Let's say in a room there are 10 people, each shake hands with every other person. 10 people, each shake hands with every other person, How many handshakes? And here again, the number of handshakes is what is asked. Different ways to handle it using permutation combination. Since we are out over that, take any pair of person. In how many ways can I take a pair of person? Pair is just selecting 2 of them. A handshake, the order does not matter whether it's A, B or B, A. So we are using a C. 10C2 is going to be my answer here. Another way to think about this logic is, let's take there are 10 people. Consider yourself to be one of them. How many hands do you shake? You would be shaking 9 hands. How many hands does the second person shake? 9 hands, 9 hands. Everyone shakes 9 hands. There are 10 of us, so 9 into 10, but as done in the diagonal cases or in the line cases, each one is counted twice, so 9C 2 ways, which is same. You could even go another way. The one person would shake hand 9 times. Let's take a second person and count the number of new handshakes. Let's not count something that is already counted. So his handshake with the first one is already counted. He would shake hands 8 times. The third person would shake 7 new hands as such. His earlier 2 handshakes are counted already, and this could continue till the last person has no new handshake, all his handshakes. So these are 10 numbers, 0 to 9. So these are the numbers. If I add 0 to 9 natural numbers, which is going to be n into n plus 1 by 2, which comes down to the same thing. So you could use logic, you could use PNC or so on. This handshakes is also similar to a round robin matches. So round robin matches, what happens in a round robin matches? In round robin matches, let's say there are 12 teams and each one plays every other. So round robin means each plays every other. Now, this is similar to a handshake. Instead of just shaking hand, they are playing a match. So the question is, how many matches will take place if there is a round robin tournament held between 2, and the answer is the same logic exactly, 12C2. What is the alternative to a round robin matches? The alternative to a round robin matches is a knockout matches. Now knockout matches refer to tournaments like the Grand Slam, any tennis tournament. So what happens out over that? Knockout. Any player who loses a match is out. He'll not play with every other player as such, right? So in knockout matches, they typically go in rounds. So round 1, whatever is the number of teams out over there, each will play against one another person. Whoever loses goes out. All the winners from round 1 will move to round 2. They will play amongst each other, not each one playing every other, each one playing one another player. Losers go out. It is not a PNC question. I would like to do the complete solution, but it's not about PNC, so I'm leaving it for you to check out. I'll just give you the answer. if there are n teams in any knockout matches, the number of matches that have to take place is n minus 1 matches. And I would ask you to do this with every possible. Usually these questions have 2 to the power n number of teams. So if there are 32 teams, ideally go and check how many matches in each round. 16, then 16 will qualify, 8 matches, 8 will qualify, 4 matches. Try to do this addition and you'll always find that it is n minus 1 matches. Now think of the logic, why is it always n minus 1?